So, I know you guys have done the scientific method before, so you should know what the first step is. The first step is asking a question. And I know a lot of you guys are curious about different topics and you have some ideas for your science fair project. So, your first item of business is to ask a question. Okay, asking a questions first. And what this involves is making observations. Maybe one day you are cutting up some apples for your lunch, and by the time it gets to lunch, your apples are all brown, and you wonder why. That's your question. Why do apples get brown? Or maybe another question that can be tested is, what can I do to prevent apples from browning? So that's your first step. Another one, the example we use in the slide is, why do some plants grow better than others? Which is a great question. But when we ask our question, if our question is, why does an apple fall down from a tree? Now in modern society, we do have an explanation for that. So that's something that we can research and find the answer to. So the next step is research. There's two reasons for doing some research. The first reason is there already an answer to this question? Have we, as a society, figured out why the apple falls from the tree? But another reason is, if you're asking the question about apples browning, maybe online you find some remedies for that. Thinking of like lemon juice, different kinds of containers. So you might find some things to test, or some things that kind of make you ask more questions. Like, why does lemon juice prevent apples from browning? So we are doing our research. And that's especially important for your science fair project, because you're going to have to write a short research paper just to show me that you know how to do research, you know what sources are appropriate, which is great. It can also help us form our question better. Maybe if we were asking, why do apples brown? Instead, we can now ask the question, what prevents apples from browning? And the next step, I know you guys know, is the hypothesis. We're going to hypothesize. Hypothesizing doesn't mean asking our question anymore. It means making a prediction. So we also use our certain format, if you want to write this on the side. If, then, because. So again, going back to my question about apples browning. Our hypothesis could be, if an apple is bathed, is placed, has lemon juice on it, then the apple will delay its browning because of the acidic properties of the lemon juice. But what I don't want to hear is lemon juice will stop the apple from browning. Not in that format. I need to see this format. These three words are a proper hypothesis. And we'll go over that again when you have to turn in your hypothesis for your project. You have to make sure it's testable. It can't be our original question. Like, our original question for apples browning was, why do apples brown? That's not a testable question. If you understand that makes sense. I think a lot of you will understand that. All right, our next part of the scientific method is a lot of people's favorite part. It's the experiment. Some people call this investigation. I think it's because they don't want to have fun and say experiments. we're experimenting. We are going to use materials. We're going to gather materials. We're also going to write our procedure if it's an experiment that you're designing yourself, or if you find a procedure, like when we're doing a lab in class, you will follow my procedure. But for your science fair project, you will be developing your own procedure. And of course, you're going to have examples of this like when we do it in class. So you're not going to be totally on your own for like the verbiage that's used. So you're also going to include controls. Controls are what you keep the same, or what it kind of gives you a baseline for what you're testing. So for example, with our apple experiment, let's say we are going to test our apples with ice water, lemon juice, like an apple container, or a container that advertises that it'll stop browning. We can use those, and then we're also going to have apples by themselves with nothing added. So we can compare the rates of browning, maybe how brown they get. Like maybe the plain apples would be a lot darker than the ones in ice water. I don't know. So we have controls. We're collecting data. So for your apple experiment, it's probably going to be more observations and days, time. But for like a plant experiment, if we're trying to see what kind of soil makes plants grow the tallest, you're going to have numerical data. You're going to have heights. But in most experiments, you're always going to use time, which is usually going to be your independent variable if you have to graph. Because what happens is based on time. So you're going to have those. And that's about it for experimenting. We also are going to talk about lab safety. I don't think any of you are going to be doing anything with harmful chemicals. But again, when you give me your draft, I'll see. Like for this apple experiment, I'm thinking maybe, being cautious about like lemon juice going in your eye, or being cautious with a knife. You'll write up like your safety guidelines. I don't expect you guys to be wearing goggles in your own house cutting up apples, but I do want you to explore what kinds of things could be dangerous. Again, knives, kind of always dangerous. Getting things in your eye, kind of always dangerous. So just kind of looking at those before you do your experiment. And you're also going to write them for me. All right, so in our top box, now that we've experimented, we have our data. We're going to analyze our data. So, what does it mean to analyze data? It means to kind of create a storyline of what happened in your experiment and what that means. So again, for our apple experiment, let's say we tested our apples in ice water, apples in lemon juice, apples in a container, and our control apples. So again, we're comparing our special apples to our control apples, our plain apples. So analyzing our data, we're looking at our observations. We're seeing, okay, the apples in ice water went 6 hours without turning brown. The apples in lemon juice took about 3 hours to turn brown. The apples in a container turned brown in 2 hours, and the plain apples turned brown in 30 minutes. And maybe with this example, we would use a bar graph, because we're not really comparing the different types of apples over time. We're comparing the different types of apples. We don't really care about the time in relation to to each other because they're all different kinds of apples. So we do a bar graph. So I want to see some kind of chart or graph. For this experiment, I'd probably want to see a chart of observations and then a graph compiling that data for visual reasons. You're also going to think about outside influences that could have occurred, especially if you get a result that you're not sure why that happened, like if it's kind of an unexpected result. Like if the plain apples took the longest to turn brown. Oh, it's because I put those in the fridge and I left all the other ones out. There's different things that can affect those. So I want to see like your possible influences. And I also want to see some photos in this part of your paper. And of course, they should always corroborate what your chart and graph says, because if I see some pictures that are not telling the story, I'm going to have a couple questions for you. So, we got our analysis done. And now we are drawing a conclusion. So now is when we look at our data, we analyze it, and now we're saying, all right, which method really did work the best? Was it the thing I said, the ice water took the longest? So we're coming up with the answer to our question. If there is a definitive answer, I can think of some experiments that you might do that maybe the data doesn't give a for sure answer, but you can still kind of draw a conclusion on your hypothesis. So you're going to refer back to your hypothesis, and you're going to see, was it correct? Was it not correct? And from there, we continue to draw our conclusion. Hypothesis correct. Hypothesis, I'm not going to say wrong, because your hypothesis can be incorrect, but that doesn't necessarily make it wrong, if that makes sense. So, regardless of which of these happens, we're still going to move on to the next step, and that's reporting data. So, going back to our apples. If your hypothesis was correct and lemon juice truly did keep the apples from browning the longest, great. Now you're going to put that in your report and you're going to let me know. And, you know, maybe you can even report that data to family, friends, depending on what your experiment is. Of course, if you're doing some random thing, like one year for a science fair, I did what kind of solution makes sugar crystals grow the biggest. And I don't know how that could be applicable to most people in my life. So I definitely reported the data in my lab report alone. But you never know. But even if your hypothesis is wrong, which it was, because we were talking about the lemon juice, and it was actually the ice water, we can still report that data. We can say, okay, my hypothesis was incorrect, but this is actually what keeps apples from browning. And if your hypothesis being wrong doesn't give you a clear answer about whatever subject matter you're discussing, that's when you go all the way back to a new hypothesis. And maybe a new design, too, of your experiment. It's just not showing up. Maybe you design your experiment differently. Use some different variables. Use some different materials. Do a different procedure. And maybe you'll get a definitive answer.